Hello everyone. In this video, I'm going to show you how to build a Roslyn analyzer. The best way to explain to you what an analyzer is to show you a built-in analyzer in Visual Studio. Here I have a C# file in which I have declared a count variable. I declared this variable, but I never use it. So Visual Studio has a built-in analyzer that is giving me a warning here that says the variable count is assigned, but its value is never used. Okay. So the analyzer I'm going to be building in this video is related to immutable arrays. In order to use immutable arrays in C#, we need to install the system.collections.immutable NuGet package. In this line, I'm creating an immutable array with a single element, which is 1. The difference between immutable arrays and normal mutable arrays is that once you create an immutable array, you cannot change its contents. What we can do instead is create modified copies of immutable arrays. For example, in this line, I'm creating a new immutable array which will contain the elements from array but will also include the element 2. So after executing this line, array 2 will have 1 and 2, but array will have only the element 1. Another way of creating an immutable array is to start with an empty array by calling the empty static property and then calling the add method. So these two lines here, they create the same immutable array. The difference is that this version is more readable, but also it's more performant. The analyzer I'm going to be building in this video will show warnings when developers create immutable arrays this way. Now I'm going to create the analyzer project. Before I go ahead, I want to explain to you that there are multiple deployment options for analyzers. In this video, I'm going to use the Visual Studio extension deployment option without going into much details about it. In other videos, I will talk about deployment options in more details. Okay, I'm going to search for the VSIX template, but I can't find the template here. So if you can't find the VSIX template here, you need to install it. Okay, here in Workloads, you need to scroll down and choose Visual Studio Extension Development and hit Modify. Okay, I'm going to hit Launch. Okay, let's try again. Okay, VSIX. Okay, I'm going to choose the empty VSIX project for C# and click Next. I'm going to name the analyzer project Immutable Array Analyzer. Create. Okay, now I'm going to create the analyzer class. In order to do that, I need to install a NuGet package. The NuGet package is called microsoft.codeanalysis.c#.workspaces. Okay, now I'm going to create a new class. Let's call it Creation Analyzer. Okay, the first thing to do is to make this class inherit from the diagnostic analyzer class. Okay, I'm going to make the class public. And then I'm going also to decorate this class with an attribute called diagnostic analyzer attribute. Here I tell the consumer of this analyzer, which is for example Visual Studio, the language of the code that this analyzer is going to analyze. Okay, so now Visual Studio is showing us red squiggles underneath the class name, And that's because there are abstract members in the base class that we haven't yet implemented in the subclass. And this really is the work of another built-in analyzer in Visual Studio. Okay, let me implement these abstract members. Okay, let me talk about the concept of a diagnostic. So we can think of the job of an analyzer as something that analyzes code and then gives the consumer back diagnostic objects. A consumer, for example, is Visual Studio. These diagnostic objects are what you see here in the error list. For example, this is the result of a diagnostic object, and this is the result of another diagnostic object. Okay, let's talk now about the concept of a diagnostic descriptor. You can think about a diagnostic descriptor as a blueprint for diagnostics. It contains some of the details about a diagnostic object, but then when you create a diagnostic object via a specific descriptor, there are some details that you need to fill, and I will show you that in a little bit. Let's create a diagnostic descriptor object. Okay, so each descriptor needs an ID. Let me give this descriptor an ID of bad way of creating immutable array, okay? And then a title for the descriptor, a message. Okay, let me talk about the message for a little bit, because this is an example of part of the diagnostic descriptor which can be parameterized. For example, when you create a diagnostic object out of this diagnostic descriptor, you can change this message a little bit by creating parameters here. In this demo, I'm not going to use this feature, but I might use it in other videos. Category, let's say immutable arrays. Then severity, this is where I specify whether this is an error or a warning, for example. So this is a warning and is enabled by default true. I want this to be enabled by default. Okay. Okay. So each analyzer must tell the consumer, for example, Visual Studio, the descriptors of the diagnostics that it might emit. So here, what I'm going to do here, I'm going to give it back our only descriptor. Okay. So through the supported diagnostics property, we have told the consumer about our diagnostic descriptors. Now we are going to override the initialize method. Okay, let me show you what we can do in this initialize method. So in this initialize method, we get a parameter of type analysis context. Let me show you what we can do with this parameter. Okay, here we can use this register syntax node action method to register an action to be called when the consumer, which is for example Visual Studio, wants us to analyze a certain syntax node. This will make sense in a little bit. Here I told the consumer that I wanted to call the analyze method when it wants me to analyze syntax nodes of type invocation expression. Okay, so what are syntax nodes and what are invocation expressions? To help myself explain these, I'm going to use a tool called the Roslyn Syntax Visualizer. In order to use this tool, we need to install the .NET Compiler Platform SDK. I'm going to run the Visual Studio installer. I'm going to modify my installation. And I'm going to search for .NET Compiler Platform. So the .NET Compiler Platform is another name for Roslyn. To use the tool, I'm going to the View menu, Other Windows, and then Syntax Visualizer. Okay, let me put this here. Okay. So when Roslyn parses a file, like a C# file, it creates what is called a syntax tree. So for this file here, here's the syntax tree. To understand what a syntax node is, let's look at an example. Let's click on this register syntax node action method. So the tool sent us to this identifier token here. So we can think of tokens as the leaves of the tree. They contain the smallest pieces of code. So the parent of this identifier token is this identifier name. And this is a node, not a token. So the parent of this identifier name node is this simple member access expression node. You can think of nodes as the non-leaf nodes of the tree. They themselves don't contain code, but they contain the structure that ultimately leads to the tokens which contain the code. So basically, nodes are important because they help us understand the structure of the code. For example, this simple member access expression helps us understand that this piece of code is a member access expression. That is, here we are accessing a member code register syntax node action in an expression code context. Okay, let's go to the parent of this simple member access expression here, which is the invocation expression. So this invocation expression node has two child nodes. This simple member access expression here and an argument list expression. It has two child nodes because it needs to know what expression are we invoking, which is in this example a simple member access expression, and then what are the arguments of invocation. Okay, going back to our particular example, here we are telling the consumer to call our analyze method when it finds invocation expression nodes, which is something like this, right? The particular invocation expression I am interested in is the add method of the immutable array class. So the invocation expression that the analyzer is going to be looking for looks like this. This would be an invocation expression, and the expression part of the invocation expression is this, and the argument list of the invocation expression would be this. Now this part would be a simple member access expression with the member being add, and the expression accessed is also a simple member expression with a member called empty, and the expression of that would be this immutable array of something here. Let me go back to the analyze method and continue working on it. Okay, so I'm going to start implementing this method. First, I'm going to rename this parameter to context. Now this parameter of type syntax node analysis context would be given to me by the consumer of the analyzer, which for example is Visual Studio. Via this parameter, I can access the node that the consumer wants me to analyze. The type of this property is syntax node, but I can safely cast it to invocation expression syntax because I ask the consumer to only give me nodes of type invocation expression. So my job now is to check whether this invocation represents something like this, right? So the first thing I'm going to check is whether the argument list has a single element. Okay. The second thing to check is that the expression of the invocation is a simple member expression, of which the accessed member name is add. Okay. Now I want to check that the member name is add. Okay. So the next thing to check is that the expression of the simple member access expression is also a simple member expression, and the accessed member of that is called empty. Okay. 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 Now I need to check that the expression of this member access expression is immutable array of something. Okay, so this kind of syntax is called generic name syntax, right? Here I verify that the expression is a generic name syntax. Now I need to verify that the number of type arguments is 1, right? The type arguments are the ones here, right? I need to verify that there is only one generic type argument here. And then I need to verify that the name of the generic type is immutable array. Okay. Now, if execution reaches here, we know for sure that the invocation expression looks like something like this. So now we are ready to report the diagnostic back to the consumer. And we do this via the context parameter. We say context.report diagnostic. And now this method takes a diagnostic object. To create it, we use the diagnostic.createStatic method. We give it the descriptor, and we give it a location in the source file where we want the warning to be reported. Here we use node.getLocation, and this gives us the location of the node. Okay, and that should be it. Okay, before trying out the analyzer, there's one final step related to deployment. So I'm going to open this file here, source.extension.vsix manifest. I'm going to go to assets, and then I'm going to add a new asset of type analyzer. The source is a project, our project. I'm going to hit OK. And as I told you before, I will talk about this in another video. I'm going to hit save, and now I'm going to hit run. So when I hit run here, this will open another instance of Visual Studio where our analyzer will be deployed for testing. Okay, let me open this project. Okay, as you can see here, there are green squiggles underneath this invocation expression. If I hover over it, it says here bad way of creating immutable array. Also in the error list, I have a warning. Here is the ID that we configured the descriptor with, and here is the description of the diagnostic. It appears here. Okay, let me try something out. Let me use the full name of the immutable array class. If I do that, the warning disappears. So this is a shortcoming of our analyzer, and I will be talking about a fix in another video. Another thing to note is that if I hover over the expression here and click the light bulb, there isn't a suggested fix. I will show you how to create a fix in another video. Thanks for watching.